right, guys, I hope you're doing well today. Today I'm going to read from an awesome book called Mixtures and Solutions. So we're going to read about what mixtures are and what solutions are and see some examples. All right, so you can follow along with me as I read. So the first thing we're going to talk about is mixtures. So the next time you're at the beach, pick up a handful of sand. Look at it closely. You will see that each grain of sand is really a tiny rock, as you can see in that picture. Not only that, but the grains are different colors. And some of the grains are not rocks at all. They're little pieces of seashells. Sand is a mixture. A mixture is two or more materials put together or combined. This sand is a mixture of black, white, tan, and gray rocks and bits of shell. A handful of sand is a mixture of several things. Mixtures are everywhere, but if you're not looking for them, you could miss them. The sidewalk is a mixture you can walk on. It is several sizes of rock mixed with cement. A bowl of mixed nuts is a mixture you can eat. So are fruit salad, vegetable soup, and carrot and raisin salad. And if you ate some mixed nuts, vegetable soup, and salad, just think about the mixture in your stomach. All right, so if I'm doing a good job of reading a nonfiction book, meaning that it's about something in real life, I'm going to pay attention to the captions on the picture. So I see that sand is a mixture. I see this is a mixture of nuts. It's two or more materials put together. This is a mixture of vegetables and water to make soup. This is a mixture of carrots and raisins to make salad. Okay, so I'm doing a good job of being a good reading detective and looking for important things that I need to make sure I notice. Okay, making mixtures. So first I'm going to look at this. A ball stays the same size and shape in any container, which I know that because I know all about salads, right? All right, making mixtures. Mixtures like sand or mixed nuts are made when two or more solid materials are combined. Solid is one of the three common states of matter. Solid objects have mass, take up space, and have a definite shape and volume. A ball, for instance, stays the same in size and shape in your hand, on a tabletop, or in a cup. Chocolate syrup poured into milk is a mixture. Lemon juice and water is a mixture. So is oil and vinegar. These are examples of mixtures made of two liquid materials. Liquid is the second common state of matter. Liquids have mass, take up space, and have a definite volume, but liquids do not have a definite shape. What do we know? Think about it. What do we know about liquids? So as I'm reading, I'm thinking about my thinking, right? I'm saying, okay, yes, I remember liquids take the shape of their container. A volume of water can have a different shape depending on whether it is in your hand, on the tabletop, or in a cup. Liquids take the shape of the container they're in. Your breath is a mixture. The exhaust coming out of a car is a mixture. The air that surrounds Earth is a mixture. They're examples of mixtures made of gaseous materials. Gas is the third common state of matter, but we can't always see gases. Most gases are colorless and transparent. Some gases, however, have color like those that make smog. We can see air on a smoggy day. All right, so I see my example of the solid in different containers and the liquid in different containers. So water changes shape depending on the container you put it in. All right, looking at this next page, I see this is a smoggy day in New York City. So this is what they're talking about, I guess, when they say we can see smog. So we can kind of see the air. It's kind of yellow. It's kind of making those buildings look different. Gases have mass and take up shape, but they do not have a definite volume or shape. They take up space. A mass of air will not stay in your hand, on a tabletop, or in a cup. Gases are shapeless and expand to fill any closed container they are in. Solids and liquids are often mixed. Salt and pepper are mixed with oil and vinegar to add flavor to salad dressing. Flour and water are mixed to make bread. Cereal and milk are mixed for breakfast. Rice is mixed with water to cook it. Gases and liquids are mixed sometimes, but often the gas separates from the liquid as bubbles. That's what happens when you pour a root beer into a glass. The carbon dioxide, which is represented by CO2 in the chemistry world, gas that was mixed with the liquid root beer forms bubbles. The bubbles rise to the surface and pop. Then the carbon dioxide in the bubbles mixes with the air. But for a while, root beer is a lively mixture of liquid and gas. Okay, so this question asks me, what ingredients make up this breakfast mixture? I see cereal and strawberries and milk. What is the liquid and what is the gas in this mixture? Well, I remember that they said the gas is carbon dioxide and the liquid I think probably has some water in it, some sugar, probably some flavoring. And I also see, guess what? I see a solid in there. What solid do you see? Ice cubes. Solid, liquid, and gas mixture. All right, so here, I see a jar with some marbles in it. So it says mixtures of solid and gas aren't often made on purpose, but they happen all the time by accident. If you fill a glass with marbles, you have a mixture of marbles and air. The spaces between the marbles are filled with air. The same is true of any solid object in a container. When it snows, the air, gas, is mixed with frozen water, solid. Dust floating around in the air is also a mixture of solid and gas. Can you have a mixture of a solid, a liquid, and a gas? Yes. Remember that glass of root beer? Just add a few ice cubes. Hey, we already noticed that. The glass of ice-cold root beer is a mixture of solid, liquid, and gas. Okay, now we have mixing solids and liquids. Remember, I'm paying attention to these headings that tell me, okay, in this next section, this section is going to be all about solids and liquids being mixed. All right, so mixtures of solids and liquids are interesting. Several things can happen. When gravel and water are mixed, the gravel sinks to the bottom of the container. If you stir the mixture, things move around, but that's about it. So we have gravel and water that are mixed together. We have powdered milk and water mixed, and salt and water that are mixed. So then we see what the cups look like after they've been sitting for a few minutes. Okay? When you mix powdered milk and water, the powder makes the mixture cloudy white. The mixture remains cloudy. It doesn't what? It doesn't separate, right? Like we saw the gravel and sand separates back into, the gravel and water mixture separates back into gravel and water. But the powdered milk and the salt water did not do that. When you mix salt and water, the salt disappears. The mixture is transparent and colorless. Gravel, powdered milk, and salt all makes mixtures with water. After stirring, you can still see the gravel in the milk, but the salt is gone. Salt is different in some way. A mixture of salt and water forms a solution. When solid salt and liquid water are mixed, the solid disappears into the liquid and the mixture is transparent. This mixture is a solution. A solution is a special kind of mixture. When a solid material disappears in a liquid, it is not gone. It has dissolved. When the solid material dissolves, it breaks into pieces so tiny that they are invisible. The solid material that dissolves is called the solute, and the liquid in which the solute dissolves is the solvent. Every solution is made of a solute dissolved in a solvent. Salt is the solute that dissolves in water, which is the solvent, to make a saltwater solution. So we know that happens in the ocean, right? I'm going to skip this just for time, but we know that happens for sure. So, here we go, taking mixtures apart. So this is very important, right? Because there are lots of times when we need to separate two things that have maybe dissolved or two things that have been put together that we could just separate with another physical way, not necessarily a chemical way, like we'll see. You made a mixture of gravel and water in class. You put 50 milliliters of water and a spoonful of gravel in a cup, and the job was done. Then you separated the mixture of gravel and water. You poured the mixture through a screen, and the gravel stayed on the screen and the water passed through. All mixtures can be separated, but not all mixtures can be separated in the same way. The physical properties of materials in the mixture can be used to separate the mixture. So we think about physical properties like size and shape and whether they're magnetic or not, whether they float or sink. Those are all physical properties. Particle size is a physical property of gravel. Particle size is a physical property of water. The particles of gravel are larger than the holes in the screen, and the particles of water are smaller than the holes in the screen. The screen can be used to separate the mixture. In class, the diatomaceous earth, which is just like a fancy way of saying just a bunch of different gravel types together. Diatomaceous earth and water pass through the screen. The particles of the powder and water are both smaller than the holes in the screen. What property will separate powder from water? The answer is size again. Powder particles are larger than the holes in the filter paper. Water particles are smaller. Filter paper will separate a mixture of powder and water. So we could do that possibly with the powdered milk, right? Other ways to separate mixtures. Imagine you open a drawer to get a rubber band. Oops, the rubber bands spill. So do a box of toothpicks and some nails. The drawer has an accidental mixture of nails, toothpicks, and rubber bands. How can you separate the mixture? You can use the property of shapes. You can pick out each piece one at a time, but it might take 10 minutes to separate the mixture. Nails are made of steel, and steel has a useful property. Steel sticks to magnets. If you have a magnet, you can separate the steel nails from the mixture in a few seconds. Magnetism is a property that can help separate mixtures. So here's that mixture right here. What about toothpicks and rubber bands? Wood floats in water, rubber sinks in water. The property of density, which means sinking and floating, can be used to separate wood, toothpicks, and rubber bands. Drop the mixture into a cup of water, then scoop up the toothpicks from the surface of the water. Pour the water and rubber bands through a screen, and the water will pass through the screen, but the rubber bands won't. Now the job is done. All right, that was really cool. So we used all of the properties of those three objects in order to best separate them. So cool. So here's the magnetism, and here's the cup of water where the toothpicks floated. All right, last page, separating solutions. Ooh, look at this. This is salt crystals under a microscope. Isn't that cool? That's what they look like when you put them under a microscope and make the image really big. A mixture of salt and water is a solution. The dissolved salt particles and the water particles are both smaller than the holes in filter paper. The property of size is not useful for separating a solution of salt and water, but evaporation will work. Evaporation, we know what evaporation is, right? Whenever a liquid changes to a gas. So it's the change of state from liquid to gas. Water evaporates, but salt does not. When a salt solution is left in an open container, the water slowly turns to gas and goes into the air. The salt is left behind. Solutions can be separated by evaporating the liquid. The salt left behind after evaporation doesn't look like the salt that dissolved in the water. Is it still salt? Yes, it is. When the water evaporates, the salt reappears as salt crystals. Salt crystals will always look square. Salt crystals often have lines going from corner to corner forming an X, so we can see that right here. Many solid materials dissolve in water to make solutions. When the water evaporates, the materials reappear as crystals. Each different material has its own crystal shape. Some crystals are needle-shaped, other crystals are six-sided, others are like tiny fans. Crystal shape is a physical property. Crystal shape can be used to identify materials. Whenever you observe square-shaped crystals in an evaporation dish, you will know that salt might be one of the ingredients in the solution. So here's 3 different crystal forms. Very cool. All right, guys, thanks for listening to that. Tune in for a little experiment.